My name is Jim Whitehead. I'm from UC Santa Cruz, and I first of all want to pass along regrets from other UC Santa Cruz people who wanted to be here, but it was just kind of a crazy week for us. And I guess I'm also just like super excited that like there's actually a room full of people within the UC system all doing interesting and substantial things in computer games. That's really pretty amazing, and like 10 years ago was not the case, and so it's really pretty neat and gratifying to see that. So we've come a long way. I'm currently in the new department at Santa Cruz, a computational media department that was formed just this past fall. And computational media is the home for computationally oriented games work at UC Santa Cruz. But the idea of computational media is certainly bigger than just games, and we're sort of engaged in an active discussion of trying to figure out exactly what that means. Computational media comes at media uses of computing from a technological background. So computing is a central part of that. However, it's explicitly designed to be a department where people with very strongly interdisciplinary backgrounds and research agendas can feel at home, and where if you're, say, crossing from computation to humanities or computation to the arts, that those are embraced and welcomed and not viewed as like some strange fringe activity on the edge of a computer science department. I guess programmatically, we have a undergraduate degree program in computer games. That's a very technologically oriented program. We're currently in the final process of creating a more design-focused games degree, a Bachelor of Arts in Games and Playable Media, and that's going to be housed in our Arts department at UC Santa Cruz. We have a professional master's in Games and Playable Media, and so Brenda and John Romero are the leads on that. And then we also have a research center in Games and Playable Media that many of you know about. My particular research, I have a research background in software engineering, which I had before the interest in games, and so that inflects my work on games a tremendous amount. So I have been doing some games with a purpose work that crosses games and software engineering. The whole idea is to create games where by playing the game you're helping move a formal verification of computer software forward. We, in that work, have been focusing on making games to have people have a enjoyable experience, but also be creating loop invariants. And a loop invariant is a kind of mathematical way of describing how a loop in computer software works. And anyway, it's been a strange and interesting trip trying to create games for such a strange, abstract concept. Also have a background and interest in procedural content generation, which has increasingly been focused more on computational creativity. I also kind of like to do sort of what I call institution hacking, sort of trying to get large institutions to do things that you might not think they ordinarily would, like, say, approving a games degree, or in the case of this most recent work, had a student who's very interested in doing procedural generation of novel cocktail recipes. So this maybe is the opposite of games for health research. This is sort of, I don't know. And of course we needed to like actually have validation of whether these cocktails were any good, and so it really was fun trying to push that through our IRB. And I did in fact get an email once that literally asked the question, "Are you serious?" Which we were, of course. So we did get our IRB approval, and we did in fact have, in an approved lab setting, tasting of alcoholic beverages. Anyway, I guess sort of the punchline there is some degree of success at computationally making these beverages, although because they were cocktails, a lot of our testers actually didn't have a lot of background in cocktails in general. So the sort of results were sort of all over the place in terms of whether they liked them or not. Let's see. Also have another student who's starting to work on procedural representations of style. We're interested as a particular domain, Lego structures. And so if you've ever looked at Legos, usually they come in sets. And so it might be like Lego Space Patrol, and then all of the Space Patrol spaceships and vehicles and structures all have kind of certain common aesthetic characteristics that let you know that those are part of the Space Patrol set and not, say, part of the Lego Harry Potter set, for example. And so the notion is, can we capture in a computational sense this notion of style, like what makes a Lego Space Patrol and a Harry Potter, and then even more, can we then generate new instances of vehicles and spaceships and so on. And of course, it lets us have an excuse to play with Legos, which is great. I guess future things I'm working on. I'm starting to get interested in the demo scene, which is this kind of odd community where people write programs and the programs generate music video-like experiences. And so there's a demo scene event next week in San Jose called NV Scene, and so I'm going to go to this and see if I can learn how people actually make demo scene programs. I guess also, been teaching our capstone software games class for a couple years now, and I don't know, it seems like every year I think I know how to do it well, and then every year some new problem crops up. So if anyone wants to commiserate and share war stories about capstone game project classes, I'd be happy to do that. And then I guess another hat I have is I'm the head of an organization that runs the Foundations of Digital Games Conference, which is here in California this year in June 22nd. So this is sort of one of kind of two sort of big tent, fairly broad computer games conferences, the other one being DIGRA. And actually, somewhat excitingly, just had a conversation earlier this week where we're talking about trying to co-locate FDG and DIGRA in 2016. So kind of look forward to that. So anyway, with that, I am done. I'm open for questions and/or getting lunch and discussing over lunch.
Questions for Jim?
All right, food.
Oh, I'm sorry. I had a question. Can you say a little bit about the work on the Lupin variants? Not so much that the specific game, but it's a multi-game endeavor. So you guys are working on part of it. So maybe talk about what is it like to work in this community of multiple teams building games that are trying to solve a similar or common problem?
Yeah, right, sure. Yeah, so this game project is supported by by DARPA, and their interest is sort of been a long-running one in software verification. Sort of the general feeling is if we're going to have weapon systems that have heavy software components, whether you like or dislike weapon systems, if they are going to exist at all, you probably want them to work correctly, and I can very much get behind that as well. The idea behind this is to have a bunch of people trying to make games to kind of make software verification kind of easier and scale better. And so there's been 5 major performers all kind of trying to make games all around this basic idea. And it's really pretty challenging to kind of do games with a purpose where you want to make a game that actually does real useful work. And so I'd say probably the main struggle we've all had is like just making a game about this topic at all is super challenging, but making one where you're actually doing useful work, work that a computer can kind of just do in and of itself, is really hard. And so this is sort of the same line that Foldit is on as well, where Foldit is trying to get people to do useful protein folding work that computer algorithms couldn't just do themselves and figure these protein foldings out computationally. And so it's the same thing where there's been a lot of work in trying to find Lupin variants or these other software verification techniques that that exist and work quite well. And so how can you have humans do something useful above and beyond that? And then there's sort of just the general challenge of sort of the more you ramp up the difficulty to make it so you're doing actually useful work, well then it gets sort of less and less kind of fun as an entertainment experience. And the whole idea of the project, I think, was to try and channel that magic that games have to make fun experiences and then kind of get useful work out. But as it gets more and more difficult, as the puzzles get harder in the games, it's sort of less and less of a fun entertainment experience and more like, man, you really have to think hard about these things. And so I guess I would say I don't know that we've necessarily kind of totally figured this out ourselves. Our first game, called Xylem, kind of explicitly had people writing algebraic equations And sort of it was fun trying to make this work at all on an iPad, but I think kind of actually making algebraic expressions is sort of not all that fun inherently. And so that was a challenge. We have a new game where it's more just about kind of viewing loop invariant finding as a kind of classification problem, and that's a little bit more interactive and a little bit more fun. And there, I don't know, I'm not sure we'll be able to get the challenge done right. So anyway, I could probably talk for hours on that. So yeah, so that's sort of some of the challenges there. All right, anyway, thanks. You've been good listeners.